Welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics, motion in a straight line, ncert solution, part 9. Our mission is to provide free classes on YouTube for all the students of class 6 to class 12 and students appearing for IIT JEE, NEET, India, NDA and other competitive examinations. Before we start, we have a small request for you. Please subscribe, like, and share our channel. And please click on the subscribe button to support us and also click on the bell icon to get automatic notification. If you have a special request to for us to create a video on a special topic or chapter, please write on the comment box. Let us begin the chapter now. In the last class, we have studied the solution till 3.19. Today we'll start with 3.20. The question is, figure 3.23 gives the xt plot of a particle executing one-dimensional simple harmonic motion. Give the sign of position, velocity and acceleration variables of the particle at t is equal to 3 seconds, 1.2 seconds, and minus 1.2 seconds. Let us see how to solve this. So, for simple harmonic motion, we also say it as SHM of a particle. Acceleration A is given by the relation A is equal to minus W, that is omega square x, which is equation number 1, where omega is the angular frequency. Now case 1, when t is equal to 0.3. Now if we divide this 0 from 0 to 1, this point, the point 3 will come somewhere here. And if we draw a line which cuts this curve, it can be cut here. So the distance x is negative here because it is negative x-axis. Now so x is negative here. Now we uh, the slope of xt plot will also be negative, and we know that the slope of a xt plot distance time graph is gives the velocity, so therefore velocity is also negative. Therefore both position and velocity are negative. Position is already proved in the graph itself, it is negative, and the slope is its velocity. Since the position is negative, slope is also negative. Let us go to the next part. From equation 1, acceleration of the particle will be positive because acceleration is negative of omega square x. From equation 1, acceleration is negative of omega square x. So since x is negative, so acceleration will be positive. Now case 2, when t is equal to 1.2 seconds. In this time interval, x is positive. How come? 1.2 second. Let us see in the graph. So 1.2 will be somewhere here. So draw a line which touches the graph. Okay, this is the line and if you draw, it will touch here. So it will touch here, and which is positive x. So x is positive here. Now, since x is positive, let us see what will happen to the velocity. So since x is positive, the slope of xt plot will also be positive. So velocity will be positive. Both velocity and position will be positive. But from equation 1, acceleration is negative of omega square x. So the acceleration of the particle will be negative. Now, case 3, when t is equal to 1.2 seconds, minus 1.2 seconds. So in the graph, let us see where minus 1.2 seconds fall. Minus 1.2 second will fall somewhere here. And if we draw a line on the graph, it will be somewhere at this point. So here x is negative. So the position is negative. First of all, x is negative. Thus, the slope of xt plot will also be negative. Since slope will also be negative, since both x and t are negative, therefore velocity becomes positive. Therefore, not velocity, this will be acceleration. So put this value in equation 1 and you will get acceleration as positive. So it is done. Now all the three cases are done. Now let us see question number 3.21. So in figure 3.24 gives the xt plot of a particle in one-dimensional motion. Three different equal intervals of time are shown. In which interval is the average speed greatest, and in which is it at the least? Give the sign of the average velocity for each interval. So the average speed of the particle shown in the graph is obtained from the slope of the graph in a particular interval of time. The slope is maximum in the interval 3 and minimum in the interval 2. Let us see the graph again. So at this point, the slope is maximum, and at this point it is minimum. So the same is written here. Slope is maximum in the interval 3 and minimum in interval 2. Therefore, the average speed of the particle is greatest at the interval 3, greatest at interval 3, and least at interval 2. So it depends upon the slope. If the slope will be more, the average speed will be more. It is directly proportional to the slope. So the sign of the average speed is positive in both the interval 1 and 2 as the slope is positive. The sign of the average velocity is negative in the interval 3 because the slope is negative in the interval. So the average velocity is positive both for 1 and 2, but for 3 it is negative. Let us see the image again. So for 1 and 2 the slopes are positive, no issues, and for 3 the slope is negative. The slope is negative. So we have written this, that for 1 and 2 the slopes are positive, and for 3 the slope is negative. Now let us see next question, 3.22. Figure 3.25 gives the speed time graph of a particle in motion along a constant direction. Three equal intervals of time are shown. In which interval is the average acceleration greatest in magnitude? In which interval is the average speed greatest? Choosing the positive direction as the constant direction of the motion, give the sign of V and A in three intervals. What are the acceleration at point A, B, C and D? So let us see the sum now. Acceleration is given by the slope of speed time graph. Very important thing. We know slope of steep speed time graph gives acceleration. In the given case, since the slope of given speed time graph is maximum in interval 2, average acceleration will be greatest. So interval 2 the average acceleration will be greatest. Height of the curve from the time axis gives the average speed of the particle. In it is clear that the height of the greatest is the greatest in interval 3. So height is greatest in interval 3. Hence average speed is greatest in interval 3. This is also clear. So in interval 2 the acceleration is greatest, interval 3 the average speed is greatest. Now let us discuss each interval. Interval 1. The slope of the speed time graph is positive, hence the acceleration is positive. Similarly, the speed of the particle is positive in this interval. So here everything is positive. The slope of the speed in second interval, in the interval 2, the slope of the speed time graph is negative here. So if you want to see the image again, you can see the slope is negative here. So here the exertion is also negative. However, speed is positive because it is a scalar quantity. So slope of the speed time graph is negative. Here slope of the speed time graph is negative. Hence acceleration is negative. But speed is a scalar quantity. So it is positive. Now what is happening in interval 3? Let us see. The slope of the speed time graph is 0 in third case. Why 0? Just check it. The slope of the speed time graph is 0, hence the acceleration is 0 in this interval, in interval 3. However, here the particle acquires some uniform speed. It is positive in this interval. Speed is positive in this. So point A1, point A, B, C and D all are parallel to the time axis, hence the slope is 0 at these points. Therefore, at points A, B, C and D, acceleration of the particle is 0. So question number 20 finished. Next 22 finished. Now let us see question number 23. So which are additional exercise. A three-wheeler starts from rest, accelerates uniformly with 1 meter per second square on a straight road of 10 seconds for 10 seconds and then move with uniform velocity. Plot the distance covered by the vehicle during the nth second. N is equal to 1, 2, 3 versus n. What do you expect this plot to be during accelerated motion, a straight line or a parabola? So let us see. Distance covered by a body in nth second is given by the relation dn is equal to u plus half 2n minus 1. This is the equation where u is the initial velocity, a is the acceleration, n is the time in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. In the given case, u is equal to 0 and a is equal to 1 meter per second. Therefore, dn is equal to half 2n minus 1. This is equation 2. Putting the value of u and a in the equation, we got dn is equal to half 2n minus 1. The relation shows that dn is directly proportional to n. dn is directly proportional to n. Now we'll plot a chart. N is equal to 1, so dn is equal to 0.5. Put the value in equation 2. So if we put the value in equation 2 as 1, so we got 0.5. 2, if we put instead of n, if we put 2, then we get 1.5. 3, then we got 2.5. 4, we get 3.5. 5, 4.56, 5.57, 6.5, 8, 7.5, 9, 8.5 and 10, 9.5. These are the values. If we put the value of 1 to 10 in this equation, we'll get the values of dn as given in the chart. Now, if we plot the graph between the chart between n and dn, keeping n in the x-axis and dn in the y-axis, we get a straight line here. We get a straight line this way. Now, since the given three-wheeler acquires uniform speed after 10 seconds, the line will be parallel to the time axis. That is after n is equal to 10 seconds. Now let us see the next question. What is our next question? Question number 3.24. So, a boy standing on a stationary lift, open for above, throw a ball upward with the maximum initial speed he can, equal to 49 meter per second. How much time does the ball take to return to his hand? If the lift starts moving up with a uniform speed of 5 meters per second and the boy again throws the ball up with the maximum speed he can, how long does the ball take to return to his hand? So, initial velocity of the ball u is equal to 49 meter per second, which is already given. We are talking about this, which is already given. Now, acceleration a is equal to minus g, that because we are ball is thrown up against gravity, so minus. Therefore, minus 9.8 meter per second square. Case 1. When the lift was stationary, the boy throws the ball, taking upward motion of the ball. So first case is when the lift was stationary, boy throws the ball. This is the first case. Taking upward motion of the ball. So it is true that we have to take the upward motion of the ball. So final velocity v of the ball will become 0 at the topmost point. Then after that it will come below. It will come, it will not move up, it will move towards the earth. So applying the equation of motion, we get v is equal to ut plus at. We got we get t is equal to v minus u upon a, that is minus 49. So we got minus 49 upon minus 9.8, that is 5 seconds. But the time ascent is equal to the time of descent. Time of ascent means the time taken by the ball to reach at the highest point from the ground. Time of descent means from the highest point the ball will come to boy's hand. So both this time are equal. So time of ascent is 5 seconds, then time of descent will also be 5 seconds, and therefore the total time taken by the ball to return to boy's hand is 10 seconds. Now, case 2, when the lift moving up with a uniform speed of 5 meter per second. This is the second case. In this case, relative velocity of the ball with respect to boy remains same, that is 49 meter per second. Therefore, in this case also the ball will return back to boy's hand after 10 seconds. So there will be no change. Now let us move to the next question. Next question is 3.25. A long horizontal moving belt given in the figure. A child runs on to and fro with a speed 9 km per hour with respect to the belt between the between his father and mother located 50 meters apart on the moving belt. The belt moves with a speed of 4 km per hour. For an observer on the stationary platform outside, what is the first A. Speed of the child running in the direction of the motion of the belt. B. Speed of the child running opposite to the direction of the motion of the belt. C. Time taken by the child in A and B. Which of the answer alter the motion is viewed by one of the parents? So let us see. So speed of the belt VB is equal to 4 kilometer per hour, which is given. Speed of the boy BB again small b is equal to 9 kilometer per hour. This is also given. See, then A, problem number A. Since the boy is running in the same direction of the motion of the belt, his speed as observed by the stationary observer can be obtained as VBB is equal to VB plus PB is equal to 9 plus 4, that is 13 kilometer per hour. Now B, since the boy is running opposite to the direction of the motion, the belt, his speed as observed by the stationary observer can be obtained by VBB is equal to VB plus minus BB. Why minus? Because it is running opposite. So 9 minus 4, that is 5 kilometer per hour. Now the C part. Distance between the child's parents is equal to 50 meter. As both the parents are stationary on the moving belt, the speed of the child is either in either direction as observed by the parents will be remaining the same, that is 9 km per hour, which is equal to 2.5 meter per second. Hence the time taken by the child to move towards one of his parent is 50 upon 2.5, that is 20 seconds. In the mentioned view by any one of the parents, answer obtained in A and B get altered. This is because the child and his parents are standing on the same belt and hence equally affected by the motion of the belt. Therefore, therefore, for both parents, irrespective of the direction of the motion, the speed of the child remains the same, that is 9 km per hour. For this reason, it can be concluded that the time taken by the child to reach any one of his parents remains unaltered. So let us see the solution for the next question. So next question is 3.26. Two stones are thrown up simultaneously from the edge of the cliff to 200-meter high with initial speeds of 15 meter per second and 30 meter per second. Verify the graph shown in figure 3.27 correctly represents the time time variation of the relative position of the second stone with respect to the first. Neglect the resistance and assume that the stone do not rebound after hitting the ground. Take g is equal to 10 meter per second square. Give equation for the linear and curved parts of the pilots. So let us see the solution. For first stone, initial velocity is u is equal to 15 meter per second, which is given. Exertion A is equal to minus g because it is moving opposite to the acceleration due to gravity. Using the relation x1 is equal to x0 plus ut u1t plus half at square. When height of the cliff is equal to x0 is equal to 200 meter, that is x1 is equal to 200 plus 15t minus 5t square. Therefore, 1 5 therefore minus 5t square plus 15t plus 200 is equal to 0. So we can write again t square minus 3t minus 40 is equal to 0. Now we'll take the common and it will come into the multiplication of two parts. So first part is t is equal t minus 8 and second part is t plus 5. Therefore, t is equal to 8 or t is equal to 5. Seconds. Since the stone were projected at time is equal to t is equal to 0, the negative sign before time is meaningless. For second stone, the second stone, initial velocity u2 is equal to 30 meter per second. Acceleration a is equal to minus g, that is minus 10 meter per second. Using the relation x2 is equal to x0 plus u2t plus half at square is equal to 200 plus 30t minus t square. At this moment when the stone hits the ground, x2 is equal to 0 and we'll put the value of x2 in the above equation. We get 5t square minus plus 30t is equal to 200. Similarly, we can write t square minus 60 minus 40. Now, t square minus 10t minus t will break here. So, we'll write minus 2. So, we'll take common and we'll get the value of t as 10 seconds or t as minus 4 seconds. So, we'll do our own calculation and find out the value of t. Hence, t is equal to minus 4 second, which is meaningless. The t's value is equal to 10 second here. So subtracting equation 1 and 2, we got x2 minus x1 is equal to 200 plus 30t minus 5t square minus 200 plus 15t minus 5t square. So it is normal subtraction. So whatever answer we got, we put it into 3. Equation 3. Equation 3 represents the linear path of both stone and stone due to like linear equation relation between x2 minus x1 and others, and the path remains the straight line till 8 seconds. Maximum separation between the two stones is at t is equal to 8 seconds. X2 minus x1 gives 15 into 8, that is 120 meter. Thus, edu accordance with the given graph, after 8 meter, after 8 seconds, there will be a second, only second to as a motion whose vibration will time in the given equation, quadratic equation. X2 minus x1 is equal to 230 t plus minus 5t square. Hence, equation of linear and curves path are given by x2 minus x1 is equal to 15-second linear path, and the second case x2 minus x1 gives the curve path. Now the next question, 27. The speed time graph of a particle moving along a fixed direction is shown in figure 3.28. Obtain the distance traversed by the particle between A is equal to t and A is equal to t is equal to 0 to seconds to t, 10 seconds. B t is equal to 0 second to 6 second. So let us see how to solve this problem. Distance traveled by the particle is equal to area under which the given graph is made up of. So half into 10 to the 10 minus 0 into 12 minus 0, that is 60. So this value is 60. Average speed is equal to distance upon time, that is 60 upon 10, that is 6 meter per second. Let S1 S2 be the direct distance covered by the particle between t is equal to 2 second and 5 second and t is equal to 5 second to 6 second respectively. Total distance covered by the particle in each time t is equal to 2 second to 6 second is equal to s is equal to s1 plus s2. For distance s1, let u dash be the velocity of the particle after 2 seconds and a dash be the acceleration of the particle. So u dash will be the velocity and a dash will be the acceleration of a particle in t is equal to 0 and t is equal to 55. Since the particle undergoes under uniform acceleration in flight, so t is equal to 0 to t is equal to 5s. From first equation of motion, that is v is equal to ut plus v is equal to u plus at, where v is equal to final velocity of the particle, and putting the value of v in the equation, we got 12 is equal to 0 plus a dash multiplied by 5. Putting the values, we got a dash is equal to 2.4 seconds. Again, from the first equation of motion, we have v is equal to u plus at, and put the values in the left hand pop-up corner. So we can write v is equal to u plus at is equal to 0 plus 2.4 into 2, that is 48 meter per second. Now the distance traveled by the particle between 2 second to 5 second, that is 3 second. So put the value of s is equal to ut plus half at square a dash t square, put the value there, and the value is 25.2 meter. For distance s2, For distance s2, let a dash a double dash be the acceleration of the particle between time t is equal to 5 second and t is equal to 10 second. From the first equation of motion, we can write v is equal to u plus at. Putting the values, we get a double dash is equal to 2.4 meter per second square. Distance traveled by the particle in 1 second is equal to 5 second to 6 second. Now s is equal to u double dash t plus half at double dash square. So now putting the values, we'll get 10.8 meter. From the equation first, second and third, we get s is equal to, add all the three, we'll get 9. S is equal to 36 and average speed is equal to 36 upon 4. So the average speed is 9 meter per second. Now let us see the problem sum. Next problem sum. So next problem sum, let us see from the book itself. That is 28. That is 28th. Now, what is the average speed of the particle over the interval in A and B? The velocity time graph of the particle in one-dimensional motion are shown. Which of the following formulae is correct for describing the motion of the particle over the interval of time t1 and t2? So let us see which is correct. Now, the correct formula describing the motion of the particle are C, D, and F. The given graph as non-uniform slope, hence the formula given the A, B, and C cannot describe the motion of the particle. Only the relation is given in C, D, F are converted into equation of the motion. And this is the end of the chapter. Before you go, we have a small request to subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification. Please write a comments on the comment box of the video. And this is the end of the today's class. Thank you very much supporting experiencedtutor.com.